Hey everyone, today we're diving into some of the biggest ideas in the entire universe. We're talking star life cycles, redshift, the Big Bang, all of it. But we're going to do it by deconstructing just the single question from a recent GCSE physics paper. We're going to go way beyond just finding the answers. We'll break down the exam strategy and figure out exactly what you need to write to get those top marks.
Okay, so here's our roadmap for today. We'll start by taking the question apart, piece by piece. Then, we'll tackle that big 6-marker on star life cycles. After that, we'll get into the really cool concepts of redshift and the Big Bang, and finally, we'll look at how scientific ideas themselves actually change over time. So, let's jump right in.
All right, first things first. Let's set the scene. We are looking at the AQA GCSE Physics exam, and specifically its Paper 2 from June of 2022. So question 06 is our target. Now, the goal of this whole explainer isn't just to cover the physics, it's to show you how to lock in every single possible mark. And we're going to do that by looking directly at the official marking guide. This isn't about guesswork, it's about understanding precisely what the examiners are looking for.
Okay, let's get to the first part of the question. And you know, it's a big one. A 6-marker all about the life cycles of stars. Getting this right can make a massive difference to your final grade, so let's really break it down.
Here's the exact wording from the paper. Now, the most important word on this entire slide is compare. That's a direct instruction. It means you have to talk about what's similar and what's different between smaller stars, like our sun, and the really massive ones. This is also what's called a level of response question, which means how you structure your answer is just as important as the facts you put in it.
So what on earth is a level of response question? Well, think of it less like a checklist and more like you're telling a story. The examiner isn't just ticking off facts one by one. They're looking for a clear, logical narrative that flows smoothly from one point to the next and builds a really complete picture.
This quote right here from the official guide tells us exactly what the examiners are trained to look for. See, to get into those higher marks, you can't just list a bunch of facts about small stars and then dump a bunch of facts about big stars. No, you have to make direct points of comparison. For example, you could say both types of stars begin as a nebula, but massive stars burn through their fuel much, much faster. That right there, that's the kind of direct comparison that scores the points.
All right, next up we've got question 06.2. This one shifts gears a bit. We're moving away from that long-form answer, and now it's asking for a very precise 2-mark definition of redshift.
So how do you guarantee you get both of those marks for defining redshift? Well, this is where the official answer guide is basically your best friend. It breaks down the perfect answer into 2 very specific parts.
And here they are, the 2 non-negotiable points you need for a perfect answer. First, you get a mark just for stating that redshift is the increase in wavelength of light. Simple enough. But the second mark comes from explaining why this happens. As galaxies move away from us, you need both of those pieces to get the full 2 marks.
This visual, which is from the exam paper itself, is a perfect illustration of this. Just imagine our Milky Way is right there in the center. As all these other galaxies are moving away from us, the light waves they're sending out literally get stretched out. That stretching shifts their color towards the red end of the spectrum. And that, in a nutshell, is redshift.
Okay, let's move on to 06.3 and see how this builds on our definition of redshift. Now, we have to actually use it as a piece of evidence to support the Big Bang theory.
So, the question is now asking us to connect the dots. How does observing redshift in distant galaxies support this massive idea that our entire universe started from a single point? Well, once again, the marking guide gives us a crystal clear 2-part answer. So here's the crucial logic. For the first mark, you have to state the observation. The further away a galaxy is, the faster it's moving away from us. That's a key fact. Then, for the second mark, you explain the implication of this. If you were to rewind time, this observation strongly suggests that everything in the universe must have started from a single, unbelievably dense point.
If we look at this diagram again, we can now add a whole new layer of meaning. See how the points further from the center have longer arrows? That's illustrating the key relationship. Greater distance equals greater speed. This one observation is the bedrock evidence for an expanding universe that started from a single event.
All right, we're on the home stretch, the final part of the question, 06.4. And this is a fantastic 1-mark question because it steps back and asks about the nature of science itself. It's all about why our best scientific theories aren't, set in stone.
So what would it actually take to overturn a monumental theory like the Big Bang? I mean, it seems untouchable, right? But the thing is, all scientific theories are provisional, and what the examiners are looking for here is just one key idea.
And here it is. The core idea is actually pretty simple. Theories get replaced when we find new evidence that just doesn't fit the old model. If we make an observation that our current theory simply can't explain, well, then the theory itself has to change. Science always has to adapt to new data.
And to make this point really concrete, the marking guide specifically says you could mention things like dark matter or dark energy. These are perfect, real-world examples of discoveries that didn't neatly fit into our existing models. They've forced physicists to refine and expand our whole understanding of how the universe works.
So let's wrap this all up. We've taken apart one single exam question, and in doing so, we've covered some of the biggest ideas in cosmology. Let's just quickly summarize the absolute essentials.
So what are the core takeaways here? First, you have to know that two-part definition of redshift. Second, you've got to be able to link the distance-speed relationship of galaxies directly to the Big Bang. Third, always remember that science evolves when new evidence comes along. And finally, for the exam itself, you have to master the structure for those big level of response questions. That right there is how you get the top marks.
And that leaves us with a final thought to chew on. The physics we've talked about today isn't some old, dusty subject. It's happening right now. As we learn more about mysteries like dark matter and dark energy, the correct answers on tomorrow's exams might be totally different. What do you think a future mark scheme might actually look like?